So all of that was what we might call data management tasks: importing data, filtering data, selecting cases, selecting variables, exporting data. What I'll show you in the remainder of this video is how to do some actual data analyses with data objects in R. In particular, some descriptive statistical analyses of both categorical and continuous variables, as well as some graphical descriptive analyses. For the remainder of this session, we will use the data set that was based on an SPSS file because it does preserve some information about the names of the variables and preserves the labels of the values of the particular variables. And specifically, we'll use the filtered version of that file, data SPSS.subset cases, which again includes only people who for variable 1 had a 1, which is just the pre-service teachers within the data set. So everything I do henceforth just uses one of the 4 data sets that we have within R right now, which is this last one. So first we'll do kind of basic descriptive statistical analyses, then we'll do some kind of basic graphical analyses. And we need to keep in mind that the way that we descriptively analyze in a statistical way categorical variables and continuous variables is different. So I've got here examples of how to describe categorical variables or summarize categorical variables, and then also how to describe or summarize continuous variables. So we'll do them in that order. So for categorical variables, one way to describe a variable is to compute or run frequency distributions, which give us frequencies, relative frequencies, and sometimes cumulative relative frequencies. So frequencies is just like the number of people who are in each category. Relative frequencies are like the percent or the proportion of people in each category. And then cumulative relative frequencies may or may not be useful for you, but they show you kind of like the percent of people or the proportion of people who are kind of at or below a particular value, which may or may not make sense for your particular application. So I have here the code for both generating frequency distributions for all of the variables within a data file, and then also code for running frequency distributions for just a particular variable within a data set, because I thought code for both might be helpful for you. But the first thing we'll do is just generate frequency distributions for all of the variables in this data SPSS.subset cases data set. One way to do that with one package is to use the frequency function within the summary tools package. Okay, so first we need to load up the summary tools package. Okay, now that package is loaded so that when we type functions within it, it knows what function it is. And then so by just simply typing the function frequency and then parentheses and then the name of the data file, this will generate frequency distributions for all of the variables in that data file, all 9 variables. So if we just run freq and then the name of the data file, it will compute frequency distributions, just like you can get in SPSS with analyze descriptives frequency distributions. So you see here in the output window, we have a frequency distribution table for all of the variables in the data set, except for variable 3, which, if you remember from above, is a continuous variable. And because we imported the data from SPSS and that variable was classified as a continuous variable, that parameter was brought into R and it knows that it's not a categorical variable. So it didn't run a frequency distribution for variable 3, which is not categorical. So we have a frequency distribution for variable 1 here, right? And variable 1 is what their position was, and this is not actually a variable in this data set anymore. It's a constant because we selected only people who have a 1 for that variable. We have a frequency distribution for variable 2, which is whether you teach in an instructional role or whether you work in an instructional role. A frequency distribution for variable 4, highest level of education. There's 5 people with a value of 2, 22 people with a value of 3, 19 people with a value of 4, 17 people with a value of 5, and 5 people with a value of 6. 7.35% had a value of 2, 32.35% had a value of 3, and so on and so forth. Here are the percentages of people who had each of these values for highest level of education. Variable 3 is not shown because R knew, because it came in from SPSS, that it was a continuous variable. And then similarly, we have frequency distributions for each of the other variables in that data set. Now, when you're looking at these tables, you might say, okay, that's great that we have the values, the frequencies and the relative frequencies, but I don't know what I'm looking at here. 60 people had a 1. What was 1? 3 people have a 2. What was 2? So unfortunately, this function does not automatically label these values for you in these tables. So if you wanted to try and make sense of the information in these tables, it might be a little bit difficult. So I've included next in the code a function from a package that allows you to just see what the value labels are so that you can make sense of these frequency distributions, and you know what this means, and you know what this means, and so on and so forth. You know what these mean. So the function to generate what the value labels are for the variables in this data set, if they were specified in SPSS before you brought them in, is just get underscore labels and then the name of the data set for which you want the value labels. That function is from the package sjlabeled. So we first need to call up that package, and then we can run the command to run this function get labels on this data set so that we have down here what a 2 means, what a 3 means, what a 4 means, etc. So if I run those, we'll get what the actual value labels are for all of the variables in that data set, except for variable 3, which did not have particular values with labels. So for variable 1, 1 was pre-service teacher, 2 was in-service classroom teacher, 3 was in-service sped teacher. For variable 2, which is whether they work in an instructional role, 1 is yes and 2 is no. So the way this works is like the first 1 has this value and then you count over. So 1, 2. For highest level of education, 1 is less than high school, 2 is high school diploma or equivalent, 3 is some college no degree, 4 associate's degree, 5 is bachelor's degree, 6 is master's, 7 doctoral degree, and 8 is other. So if I wanted to make sense of the information in the frequency distributions above for highest level of education, I could refer down to those labels. So we had 2, 3, 4, 5, and 6. 2, 3, 4, 5, and 6 were these in that order. Okay, so that can help you make sense of the information that's in those frequency tables. When we were running frequency distributions to describe these categorical variables here, we just ran frequency distributions for all the variables, but you might not want to run all the frequency distribution tables. You might just want to run a frequency distribution for a particular variable. So you can do that with the frequency function, just as before, if you add a little bit of extra code that says which variables you want to generate a frequency distribution for. So if you look up here, the code was pretty simple for running frequency distributions for all, freq, and then the object on which the frequency distribution function operates. If we tweak that a little bit by adding a little bit to the code, we can just run a frequency distribution for a particular variable. So if you notice here how it has $var2 and $var4, that will run this function on this data set, but only variable 2. And here we can run a frequency distribution on this data set, but only for variable 4. So let's do that. We'll load the package that contains that function. And then if we just want a frequency distribution for variable 2, we'd run that code, and it'll give us just a single frequency distribution for variable 2. And variable 2 is the name of the variable. If we just wanted a frequency distribution for variable 4, we'd put the same thing, but just $variable 4, var4. So if we ran that, we'd get just the frequency distribution for that variable. But we could still run into the same problem that we ran into before, which is that we might not know what these different values represent. So we could run a function to spit out for us what the variable labels or the value labels are. So again, the function to do that is get_labels, or one function to do that within one package to do that is get_labels, and it's a function from the library package. So if we load up that package, and then if we just want the value labels for variable 2, we can write code very similar to like we wrote up here, but we could just add at the end $var2. So it'll give us the value labels for just variable 2 within this data set. Or we could run just the value labels in this data set for variable 4, which are the two variables that we tried to summarize or describe. So if I run this, it'll give me the value labels for just variable 2, right? 1 is yes, 2 is no. And then for highest level of education, if we did the same thing, we get just the value labels for that one variable. So if we put those two things together and look at them, right? So 1, 2, 3, 4, 5, 6, 7, 8. We got 2, 3, 4, 5, 6. So there's 5 people with a high school diploma or equivalent, 22 people with some college, no degree, and so on and so forth. There are 19, 17, and 5 people with an associate's, bachelor's, and master's degree, respectively. So that was describing, in a statistical way, categorical variables. But there's also, you'll recall, a continuous variable in our data set. We have all of the ages for the pre-service teachers who were selected in this data file that we're working with. So for continuous variables, there's a different way that we can look at the distribution and summarize the set of scores by doing kind of traditional descriptive statistical analyses, looking at things like the mean, standard deviation, skewness, kurtosis, minimum, maximum range, etc. So there's all sorts of descriptive statistics that we can use for continuous variables. And there's lots of different ways to compute descriptive statistics for continuous variables in R, from different packages, different functions, lots of different ways to do it. So I've modeled for you here how to use the summary function, which is a default or base function within R that we don't need to use a package for. And then there's also some functions within the psych package, describe and describe by, that might be useful as well. So I'll show you how to do both. So for the summary function from base R, we can either generate descriptive statistics for all of the variables within a data set, or if there's just say, one variable that's continuous that we want descriptive statistics for, we can run descriptive statistics for just that variable, just like we had done above. So if I run summary and then the data file, it'll compute descriptive statistics for all of the variables in our data set. So let's just run that. So then we get information, certain information for all of the 9 variables in our data set. And these are descriptive statistics here. So, but the problem is that this is 9 variables, descriptive statistics for them, but only one of them is continuous. So only one of them we would want to try and characterize with like the median or the mean or the standard deviation. So really the only descriptive statistics we probably want to look at here are for variable 3. So we might say, well, I don't need descriptive statistics for variables 1, 2, 4, 5, 6, 7, 8, and 9 because they're categorical variables. There's no point in computing a mean. That doesn't make sense. So if I wanted to just run descriptive statistics for the variable that's continuous, I could write code that's very similar, but at the end, I include $var3. And so that allows me to do a descriptive statistical analysis for just that variable within the data set. And you should know that it's a lot of different functions allow you to just specify a particular variable at the end, right? So we did this, we're doing this here, but we also did this above with different functions. This is a common way of picking only a particular variable that we use a function for. So let's just run descriptive statistics for only variable 3. So that gives us, it's oriented differently, but for the age variable, variable 3, we've got the minimum, maximum, mean, first quartiles, third quartile, and the median. Okay, so that might be the information that you're just looking for. So that's how to do descriptive statistics using the summary function within R. The problem with that one, while it gives you the minimum, the maximum, the mean and median, and then first and third quartile, you don't get the standard deviation, variance, skewness, kurtosis. There are other descriptive range. There's other descriptive statistics that this summary function within the base R just doesn't give you. So there are benefits to other packages with descriptive statistics functions like those in the psych package. So here I'll show you how to use both the describe function for descriptive statistics and the describe by function for descriptive statistics, which actually allows you to compute descriptive statistics for variables for 2 groups at the same time in case you want to compare the descriptive statistics in 2 groups. So first we'll do the describe function, which is just computing descriptive statistics for variables in the full group, the full data set. And I'll show you how to do that for all the variables at the same time, and then just for a single variable. So the function describe that we're using here is from the psych package. So we need to load up that psych package. So we can load it up. And then if I want descriptive statistics for all the variables in that data set, data SPSS.subset cases, I just type describe parenthesis data SPSS.subset cases. That's just the name of our data set. So if I just run that, it'll give me a table that looks a little bit different with a little more information than we had gotten with the summary function from base SPSS. So we have, it's oriented a little bit differently, but we got the mean, median again, the minimum and the maximum again, but we have some additional descriptive statistics here, the standard deviation, range, skewness, kurtosis, etc. But note again that for variables 1, 2, 4, 5, 6, 7, 8, and 9, it might not even make sense to compute descriptive statistics, things like an average, right? The average race, that's not a thing that we want to compute. So really the only row that we'd probably look at here are descriptive statistics for our continuous variable. So instead of cluttering up your output, we could have just told it only do this for variable 3. So if we queued up the psych package, and then did describe only variable 3 in this data set and ran that, it will give us a simpler table with just descriptive statistics for the variable that we would want to do that for. Okay, so now we have just the descriptive statistics for variable 3, which are the same as right here. 28.96 was the mean, 28.96 was the mean. Okay, another thing you might want to do sometimes is compute descriptive statistics for two different groups in case you want to compare maybe sample means in two different conditions, say, of an experiment. So there is a function for that automates that for you. So instead of having to manually filter your data set twice so that you have just this group in one data file and just this group in another data file and then run descriptive separately, you can actually run descriptive statistics while defining group membership so that it gives you two sets of results, one for one group and one for another, or for each of the groups that are defined by a particular variable. So describe by is the function that you could use for that. And so if we queue up the psych package, which is where that function is, and then do describe by these variables in this data set, but we want to specify a grouping variable of group of var2. So this saying group equals quotation marks var2, it's going to run the analysis twice, once for each of the groups that are defined by variable 2. And variable 2 here is whether they're currently teaching. So we have a 1 and a 2 for that variable, people who are currently teaching and people who are not currently teaching. So it'll actually give us two sets of outputs. But we could also do it by, race if we wanted to, or highest level of education. We could change this to var4 if we wanted to run descriptive statistics for the different education groups. So, but I just picked var2 for arbitrary purposes. So if I run that code, it's going to give me two sets of results, two sets of descriptive statistics. These pertain to people who have a 1 for variable 2, and these pertain to people who have a 2 for variable 2, right? But you might run these and say like, oh, okay, the mean age for people with a 1 is 29, and the mean age for people who are a 2 for variable 2 is 27, but who's who, right? Who's group 1 and who's group 2. So again, we could use that function where we get the value labels, or we could use another function that's a base function in R called str to queue up a little information about variable 2 so we know what's a 1 and what's a 2. So this is another way to get information about the value labels for a particular variable. So I'm just showing you a different function now, but we could have used the one that we used before, get underscore labels. So if I run this, it'll give us a little bit of information about variable 2. Right, so it's going to give me some information about variable 2 within this data set, which is the grouping variable we used here in case we want to check who's 1 and who's 2. So if I run that, now this information is not the most beautifully presented, but if we look down here, we see that you can have a 1 or a 2, and that a 1 and a 2 correspond to a yes and a no. Okay, so if we look back to our tables here, these are people who are currently teaching, yes, and these are people who are not currently teaching, no. Okay, and it kind of makes sense that on average, people who were currently teaching were a little bit older, they have more experience, they've gotten further along in their careers, more opportunities to teach and make their way into teaching.